Hey guys, how you doing? So today we're going to be talking about lesson 3.2, which is exponential decay connecting to negative exponents. So exponential decay, definition of it is kind of like the opposite of exponential growth, where when you take the initial term and you multiply it by a fraction, which is between 0 and 1, to produce the next term. Okay. So the general formula for this is the amount at time n is equal to the original amount multiplied by the decay factor d by the number of years. So in terms of when we're talking about half-life, because we're going to be talking about a lot of half-life questions, you can rewrite this as the n is equal to a o to the 1/2 to the t over h. Okay, so this is the amount at time t. That is the original amount. That is just leave it as a half because we're talking about half-life, right? The h denotes the half-life. Finally, the t denotes the time. Okay, you just gotta make sure that both time and your half-life are in the same units. Okay, so if your half-life in the question is given in years, then your time has to be given in years. If your half-life is given in days, and your time has to be given in days, and so on. But I'll explain it further when we get to the example. So here's the example. Okay, plutonium-239. So let's zoom in here. Plutonium-239 is a highly toxic waste material that has a half-life of 24 years. Determine approximately how long it will take for a 50 milligram sample of plutonium to decay to 10% of its original amount. Okay, so first method I'm going to teach you how to use is trial and error. Okay, so if we plug everything into our original equation here, okay, the time at time n, which we want, the amount at time n that we want is 10% of 50 milligrams, so it's 5 milligrams. Okay, the original amount is 50 milligrams. Okay, now I put the half factor in there. Then I have t over 24. Okay, so t over 24, pretty much, because my 24 is in the unit of time, in unit of years, then my t has to be in years as well. Okay, so if we simplify this expression, we take 50 and move to the other side, divide both sides by 50, we get 0.1 is equal to 1/2 t divided by 24. Okay, so here's where the tricky part kind of comes in, because there's no real like operation that I can do to solve for t. It's not like we can divide both sides by 24 or something, because this is an exponent, right? So next year you'll be learning logarithms, with which you will be able to determine this like algebraically, but for now, in grade 11, you guys can only do it using trial and error. Okay, so I'm just gonna just to simplify things a little bit, I'm gonna let x equal to t over 24. So I have 0.1 equals to 1/2 to the power of x. I'm just doing it just for simplification. You don't really need to include this step, but just for the ease of guess and check. So pretty much I'm just plugging in values into my calculator for x in order to get 0.1. So 1/2 to the power of something has to equal to 0.1. So first I'm going to try, like, here's just really just guess and check. So I'm going to try when x is equal to 5. So 0.1 equals to 1/2 equal to 5. And the answer I get while plugging into the calculator is not actually 0.1. It's let's see here, 0.03125. So this is much lower than what we want. We want 0.1, right? So let's try something a little bit lower. We'll try, say, 2. Okay, so 1 half to the power of 2 is 0.25. Okay, which is now too high. Right. So next we're going to try 3. I get 0.125. So we're getting closer and closer. Okay, so next I'm going to try just 3.3. Okay, and I get 0.1015. Okay, now that is a guess. That's pretty close enough. Okay, because it's 0.10, so that would be a pretty good estimate. So now when I sub in 3.3 for x, okay, I'll get 3.3 equals to t over 24. Okay, so then I multiply both sides by 24 to isolate for t. So t is equal to 79.2. So it will take 79.2 years for plutonium to decay to 10% of its original amount. Okay, so that's my final answer there. Next, another method other than trial and error is by using graphing technology. Okay, so for using a graph, we first got to graph it. So our original equation here was 0.1 equals to 1 half x, but we can use this original equation here instead, which is 50 multiplied by 1 half to the power of t over 24. Okay, so let's go here. So I got 50 multiplied by 1 half to the power of, instead of writing t, I'd write x just for the program, x over 24. Okay, hit graph. You can't really see it. Alright, so because I zoomed out a little bit, you can pretty much see what's going on now. Okay, so you can see here how it kind of just goes downwards. This is what exponential decay graphs always look like. Okay, and you'll see that at time 0, okay, you'll see that y is equal to 50. So look down here in this corner. It's going to tell you for what x value will give you what y value. Okay, red dot means y value. So when x is equal to 0, okay, I get approximately y equals to 50, which makes sense. Okay, and then after 24, it should decay to exactly half of 50. Okay, so at 24, as you see, it's y is about 25. Okay, and then after another 24 years, okay, it'll be half of 25. So we should get about 12.5 milligrams after 48 years, which is true. See, about 12.5 down there. So I don't really care. I'm just showing you that kind of stuff. What we need to find out is when this will decay to 5 milligrams. Okay, so I'm gonna go and find until I hit a y of 5. Okay, which is right about there. So my y is about 5, and it says that my x is 79. I would say 79.2. Okay, 79.2. So for using a graph, okay, you gotta use your graphing technology, draw it out, and then you gotta trace the graph until you find a point that is about 79.2 and 5 milligrams. Okay, so final answer is 79.2 years. Okay, so that's the end of that example. Okay, next we're going to talk about negative exponents. Okay, the rule for negative exponents is pretty simple. It's when I have a to the power of negative n, it's equal to 1 over a to the power of n. Okay, all the negative does is make the reciprocal, because originally this is a over invisible 1, right? So now it flips it and makes it 1 over a to the power of positive n. Okay, so just doing a quick example to illustrate this. So 2 to the power of negative 3, okay, is equal to 1 over 2 to the power of 3, which is equal to 1 over 8. Okay, so next up, we're going to do rationals. Okay, so a over b to the power of negative n is equal to b over a to the power of positive n. Okay, so quick example, 2 over 3 to the power of negative 2, okay, is equal to 3 over 2 to the positive 2, which is equal to 3 to the 2 over 2 to the 2. okay, which is then 9 over 4. So really is not too bad. Okay, negative exponents, some of the questions are going to get sort of tricky. So I'll give you just one more example here that involves variables. So I have 2u 3v negative 2 all to the power of negative 3. Okay, so first I gotta do this. Okay, make the reciprocal and make it to the power to a positive exponent, right? So then I now distribute this power of 3 to all the terms. Okay, so 2 to the power of 3 is 8. And then u, remember when you have an exponent to an exponent, okay, you have to multiply. So this becomes 9, and then v, this becomes negative 6. Alright. So now this v, because it's to the power of negative 6, you can move that to the top and let it be a positive exponent. So I have v to the power of positive 6 over 8u 9. And that's your final answer there. Alright, so that pretty much sums up this whole lesson. So just do the homework. Hopefully you guys will understand it, and I'll see you guys on Wednesday.